Yes. Okay. Okay. Good. Fine. So I'll just give you a brief of what we had covered in last lab. Right. We had programmed two commands. Right. One was PWD and the other was LS. And before we ended the lab, I asked you to code the recursive version of LS, and I hope most of you have already submitted. Right. So I hope you are clear with that. So you are supposed to just use the string concatenation functions, right? And I hope all of you use that, right? Is that the case? You had to generate the paths, right? And then you were supposed to recurse with the same path, right? So that was the case when we discussed the ls command. Now, as we have enough knowledge regarding processes, right? So today we are going to start with an important part, that is process creation and process termination. Fine. As of now, we'll not be focusing on killing the processes because you know the command for that, and most of you have used that in your first semester as well. So today I'll just focus on the process creation, and we'll see how the processes are created in detail. Okay. So the approach will be a bit different as this is the third lab. Uh, Up to last time, I had explained you the man pages, right, in brief. Okay, and then I asked you to write the code. Today, uh, I'll give you the function or system call name, and that you need to refer to first. I'll give you some time. You read that man page, okay, and then we will discuss about that. Is that fine? Right. So you will get used to reading man pages. That is my reason behind this. That is my intention behind this approach. Okay. And yes, definitely while reading, if you have any doubt, you keep that in mind and you can ask that later on. Okay. So we'll go with that approach. So the first topic for today is process creation. Right. So if you remember from class, can you give me some reasons for process creation? If anyone remembers that from our Monday's lecture. Why do we create a process? Yes. To do task. Yes. Very good. Precise answer. User initiates. Yes. That's correct. To execute some task. Yes. Anything else? Anyone else would like to answer that over here? Achieve the desired result. Yes. So basically, whenever you want to execute a program, right, we create a process, right? Now, the reason of creating the program or executing the program may be user request, or it may be a scheduled execution, right? That process is scheduled to execute at this point of time, right? Depending upon your dispatcher, okay? So that is what is the essence of process creation, right? Now, in case of, again, we are not going to touch upon the Windows concept right now because we'll stick to the Unix throughout all the labs, right? So the system call that is being used for process creation is known as fork system call. FORK, that is fork system call. Okay. So using fork, a parent can create a child process. Okay. A parent process can create a child process. That means you should have one process active currently, right? And which is going to create another process. Okay. And then the question remains is, after you create a child process, what will remain common across all the processes and what is going to be shared still? Yes, duplicates the parent process. That's correct. Right. So it is 1:30. Now I'm giving you around 10 minutes to explore fork system calls man page. Okay, go through it once. After 10 minutes, we'll take a review and I'll explain that in detail. Okay, but before that, I want you to understand that concept yourself. Understand how parent creates a child and what happens after the child is created. Okay, so that is the first task for you. Study of main page of fork. How will you open the main page of fork? Remember, it is a system call, right? Yes, I know you can also write man fork in some of the newer systems. Yes, but what is the index number? Yes, man 2. Yes, that's what I was looking for. Man 2 fork. Right? Manual 3 is for library functions or C functions. Manual entry 2 is for system calls. Is that fine? Yes, so now you continue reading the man page. After 10 minutes, we'll discuss that and then we'll write some simple programs. Okay, fine. So meanwhile, if you have any doubt, you can post that in the chat. Okay, I'll solve them out when we'll discuss. Okay, so have you gone through the basics of fork? Yes, good. So let me share the manual with you so that we can start discussion on that. And if you have any doubt in between, you can ask. Okay, so again, as I said, what you should be knowing first is the header file, right? The header file over here is unistd.h. Fine. Then comes the signature of the system call. Again, it is just a simple signature. You don't have to pass any parameters, right? And the third thing you should focus on in the return type. Okay. So a parent process will be creating a child process. Fine. So as a parent process, what we should know regarding the child? What is the basic information we require regarding the child? Can anyone tell me? Is a parent process when you are creating a child process? Yes, you should know PID of child. That's correct, right? You should know child process ID. Okay. So basically, when fork call is successful, right, you will have two same size processes. Am I saying this correctly? Same size processes. Everything will be duplicated. Yes or no? Yes. Right? So, what is the benefit of doing this? Why can't the OS create a process? Can you tell me? Why we need fork? In which situation? Can you give me one example where you have seen fork taking place? That might be one of the way to answer. GitHub. Okay, so that is an application example. Yes, but regarding Linux, shell. Yes. So on shell, when you type cat command, on shell, when you type cat command, can I say that it is creating a process? Only minor changes are needed, like we need to create different branch from that instance. Yes, that's correct. When I do cat, just a simple, for example, any command, right? Let us say cat, ls, cp, anything. Whenever you type that command name, when you press enter, are we creating a new process or it is being executed inside the given process? What do you think? New process. Yes. Good. I'm getting multiple answers with new. Nice to see that. Okay. So, who is the parent of that new process then? Who is the parent of that new process? Terminal or your shell? Yes. Very good. Fine. So that is what I wanted you to explore. That is, whenever you type in any command at the terminal, right, it basically creates or it forks a process. It forks a process, right, and then the job will be assigned to that process. Okay, so that's how the parent and child relationship takes place. Okay, understood all of you? That much basic. Yes. Okay, good. So now let us go through the details which are given in the main page, right? It returns the PID underscore T type, right? Now this is again a derived data type, right, of integer. So we should, if you want to use this, then it's okay. Otherwise, you can also use integer, right? Simple integer. You can use simple integer in place of this PID underscore T data type. Okay, so don't confuse with that. By default, the process IDs are integers, right? So that's why you can definitely declare the PID as integer. Okay, so for creates a new process by duplicating the calling process. Right. For example, shell is invoking ls. Right. So for ls, it will create a new process that will be called a child process. Right. It will be an exact duplicate of calling process. Okay, except for the following points. That means what I asked you was what is common and what is different. Okay. So can you tell me what is going to be shared between parent and child? What is going to be shared or what is going to be common somewhere? Hmm, yes, you can say resources and data. So whatever is there with parent, that will be given to the child also by default. But is child going to use the same resources? Can we say that? No, right? So that means child is designed for a separate purpose, right? So although everything is copied as it is, but that is not going to be used later on. Fine. But which entity? It might take some content. Context, yes, that's correct. Some context information is required, and context information basically is nothing but the PIDs, right? Child will know the parent by its parent process ID, and parent process will know. Yes, PPID will be different, definitely. Okay, so if you raise this point, Rishil, I would like to ask you one more question. Which is the main process in your terminal? Which is the PID of that? Which process creates the others? PID1, that is init. Very good, right? If I say about shell, right? So can I say shell is a child of init? Can you say that? Yes, again, we need to verify this, right? But if there is a parent-child relationship between shell and init, we can say that, right? Init is the first process that starts when your system boots, okay? With init, we have one more process. Anyone knows that? Which begins execution? As soon as the system starts, it is zero, zero, PID zero, that's right. And the name, what is the name of that? PID zero is called dispatcher, not the root. PID 0 is known as a dispatcher, right? And that's what you are studying. Got it? Yes. So remember these two basic aspects. PID with 0 is your dispatcher. PID 1 with 1 is init. Init is generally called parent of all processes, ideally, right? Okay. So that's what we have seen as basic, right? On success, what fork returns? It returns PID of the child process to the parent process, and it returns 0 in the child. Remember, this is a very important point to understand. We are going to call fork only once, right? But it returns with two values to two processes. Is that statement clear? We are calling fork once, but it returns two different values. What it returns to the parent? What it returns to the parent? PID of child. Yes. And what it returns to the child? 0. Right? Anyway, it is going to return. Okay. Anyway, it is going to return, but it returns with different values. Okay. If there is any error, right? So, can anyone tell me? Yes. How it returns two values? Actually, Sainish, what happens is you have two processes, right? After fork is successful. Yes or no? You have two processes, right? And both the processes are having the same code. Can I say that? Both the processes are having the same code, parent and child, because parent is the, or you can say child is the exact copy of your parent, right? That is why it returns once for the parent and second time for the child. Got it? And there is no point in returning the PID to the child process, right? Because PID, child is not interested in knowing its own PID, right? So that's why it is returning with 0. Okay, that is a standard procedure that designers have used. In case of error, it returns -1. So can anyone tell me what are the reasons of process creation failure? Process creation failure. Less resources. Yes, less space. Correct. Correct. Right. Basic reason is there is no memory available. Right. Then there can be any other reason possible, but main reason is there is less memory available. Yes, it can also be due to permission. Right. Yes, it is also possible that parent would kill the child, right? So as I said, many possible reasons, but the major reason is invalid system call will be actually a syntax error. Right? So I think that will classify under syntax error. Fine. So your system will not be able to detect that call, right? Maximum PID is reached. It's very good point. Right? Maximum number of processes, if they are already created, then it will be limiting, right? But one major reason, as I told you, is lack of memory. Because what you require over here is memory, right? That is the first thing. Plus, you should have the permission, right? Okay. So that is the basic of fork system call. Now, what I want you to do is write a simple program, right? Write a simple program where you have to call fork once, right? You have to call fork once, okay? And then print hello message using printf function again, right? No need to use write over here. You can use simple printf, right? And print hello. Can you do that much? And let me know the response, what you are getting. Yes or no? Yes. So try that out. Yes, sure, yes. What you need to do is you have to call fork once. Why I'm calling fork once? Because I want to create only one child process right now. Okay. And then you should print hello message. Okay. So report me what you get in the output. Okay. After you do this 2 or 3 lines of code. Okay. So I'm giving you around 5 minutes. Try that out. Okay, and report your status and the output that you are getting. Okay. Yes, yes, sure, Sahil. I'll explain you those statements. Yes, good. Child set of pending signals initially empty. Okay. So basically, see, Shail, ideally what do we have is we have signaling mechanism, right? Uh, every process can send signal to the other process, right? Because if you are supposed to wake up that process or if you want to assign some task to that process, right? The Unix uses signaling system. Okay. So in case of child, the pending signal, that means the signals to which you have not responded, will be empty, right? Because child is a fresh process, right? It will be handling in its own, right? So that's why it will be empty. And child does not inherit semaphore adjustment. So semaphore adjustment is again a concept of process synchronization. So that we'll be studying in chapter number 5, right? So basically it is used to synchronize between two processes, right? So whatever variable, whatever declaration that parent has made, child has no use of that, right? So that's why it does not inherit those values. Right? And as I said, in chapter number 5, we'll see semaphore. So at that time, we'll be clear with that term, right? Clear? Yes. Okay. So 2 times hello. What about others? Are you still getting 2 times hello? Yes. Good, good, good. So why it is 2 times? That is my first question. We are running only one program, right? Why it is 2 times hello? Child and parent. Exactly. Exactly. Right? So now try one more thing, right? In the same program, add one more fork call, one more fork call, fork twice, right? Not required, not required. It is not supposed to be in loop. You can just type no, not after print, fork twice and then printf, fork twice and then printf, four times, four times hello. Yes, that's correct, right? Now take a pen and paper with you, right? I hope all of you have that, right? And try to draw the tree and verify why you are getting four processes. Can you do that? Yes, that's what I want, Urjit. Take out pen and paper and try to draw the tree for the same. And let me know whether you can form a tree or not. 2 more minutes I'm giving you for that. So for example, if you are assuming that P1 is the parent, right? P1 is calling for, right, which will create C1, that's a child 1. Okay, if my for call is just once, okay. So what will happen when you call for once again? P1, C1, P1, C2, partially correct answer. Anyone else would like to try, and have you tried to draw the tree? P1 has created C1, right? So how many processes we have at present? P1 has created C1 after first for two processes, right? Now the program counter in both the processes. Listen to my statement carefully. The program counter in both the processes is pointing to which line? Suppose I've written the code like this: for, and then printf. After first fork, as we have seen, we have two processes, P1 and C1. Right? Now the program counter in both the processes will be pointing where? Second fork line. Yes, that's what I want you to understand. Second fork line, right? Because first fork has already been executed, right? So the program counter in both the processes, P1 and C1, right? It is pointing to second fork line. Is that clear to all? Yes or no? Remember, we have two processes, right? Equal. Sure, Sanish. Yes, right now I can explain you that. I'm going to explain that. Don't worry about it. In form of statements, right? So we'll try to visualize that as it is a tree. Okay. But right now, at least can you understand that much? P1 has created, or P1 called the first line fork. All of you agree with that? P1 executed the first line fork. Yes or no? Right. Now after that fork executes, right? We have two processes with same code. Yes or no? We have two processes with same code. Yes? Good. Now, both the processes would like to get dispatched immediately. But can we run both at the same time? We are having single CPU, right? So only one will run. Fine. So we assume that parent runs first. Okay, we assume that parent runs first. So which line parent will be executing, or P1 will be executing? Which line P1 will be executing? Fork. Yes, specifically Urjit and Sainish. Are you able to understand this? P1 will be executing this line, right? Fork. Okay. That is second fork. Okay. That I've written. That will create another process. Okay. Screen is not visible. Yeah, sure. Actually, can you see it now? Daniel? Yeah. Okay. Thank you. Fine. So what I wanted to convey is P1 will execute second fork. P1 executes second fork. That will give me C2. Yes or no? Because again we are creating a fork, we are calling a fork. Are you able to understand this, Urjit, Sainish? Yes, P1 is calling second fork. That is going to give you what? P2. Okay, or you can say C2, that is your child 2. Okay. Now, after first call, you get C1. That's correct. That's what I said, right? Yes. And then P1 will continue, right? So P1 will be continuing with the second fork, right? It will create another child, yes or no, Urjit? Right? So I am naming that as C2. Okay. Now what will happen to the child process C1? Whenever it gets a chance, which line it will execute again? Yes, I'll answer that, Janil. Yes, child also execute the second line because the program counter is pointing to the fork. All of you agree to this? Yes. Please be clear with this, right? Okay, good, good. So now, which process I'll be having? C3. Can I say that? Yes. Okay. Now draw the tree and let me know whether you understood or not. P1 will have two children. P1 will have two children, C1, and it will stop Janil. I'm coming to that point. But first, let me know P1 will be parent of which two processes? C1 and which is the next? C2. That's correct. C1 and C2. Very good. Right? And C1 is parent of C1 is parent of C3. Yes. Yes, exactly. Now, I think the tree is clear, Urjit. Understood? So we have how many processes total? Four, exactly. And if I ask you, how many child processes? What would be the answer? This is a common gate question, right? So you should know the equation. That's what I'm trying to focus on. Okay, good. Do it three times. In the same program, fork, one more fork. Right? Three times fork and printf. Give me the result. What happens? Total 8. Yes. Yes, exactly. Right? So can you tell me what is the total number of child processes? Total number of child processes. I'll explain that, Janil. Coming to that point. 2 raised to n minus 1. 2 raised to n minus 1. That is number of child processes. Is that clear to all? 7 total processes, right? And okay, sorry, 7 child processes. And if someone asks you how many processes will be there total, then what is the equation? 2 raised to n. That's correct. Good, good. And so that is what I wanted to explain. That's a important concept. Why C1 won't call for second time? The reason for that, Janil, is the program counter will advance to the next line, right? In every program, when you execute the first line, it will go to the next line, yes or no? And that is why it will not be executing the same fork once again, right? Are you able to follow this? Yes? Yeah. So I'm giving you 3 more minutes. Can you draw the tree for that 8 case? or 7 children case? Done. Very nice. The others, can you please do that and report? You should have a tree, right, with total 8 processes. One main parent and the other child processes, right? Purjit, are you clear with that now? Parent and child relation? Yes, good, good. And others, please draw the tree and let me know once it is done. Okay, Keval is completed, good. So if some code is before fork, yes, yes, you can try out Janil. If you are writing that code before fork, that means it will be executed by only the parent process. That line will be executed by only parent process. I hope you are getting my point. Yes, Janil? Yes, yes, exactly. So this is a tricky aspect of operating system, right? Fork system call, if you understand it thoroughly, you will be absolutely clear with it, right? Okay, now I think most of you are clear with this now. I am going with two more concepts. Child is only created by fork. Yes, that's correct, Sanish. There is only one way to create a child process in Unix, that is fork. Right? Yes. So now you can easily imagine when shell creates a process for the cat command, right? It is executing a fork system call in background. Yes or no? It is executing a fork system call in background. Right? And that is why we are getting another process. Okay. Now I'm giving you another task. Just look for two more terms. Sure, Janil, I'll repeat the same process. Don't worry. You will be clear, then only I'll go ahead. The others who are clear can go for study of what is zombie process and what is orphan process, right? Just try to go through the concepts of these two. Then we'll continue. Okay. Yes, Janil. So what you are not clear, can you please be precise? Tree structure. Okay, okay, good. Number of parent process 2 raised to n divided by 2. Yes, you can say that, but there is no standard equation for that. Janki? Generally, the question is asked regarding this. What are the total number of processes? That is 2 raised to n. And what are the number of child processes? That is 2 raised to n minus 1. Yes, tree structure generally. So I'll explain you the same example with two forks. Right? Suppose you have fork, and printf. Okay. So E1 executes first fork. Right? Are you clear up to this? Yes, right? Now after this, what will happen? Your program counter in both the programs will be at which line? Second fork? Yes or no? Program counter in both the programs, that is parent and child, is at the second fork, right? So now P1 and C1 both will execute second fork. Is that correct? Yes. So now both of them will create one more child, right? So P1 will give you C2 and C1 will give C3. Yes, yes, that's correct. I think now it is fine, right? You can map it out for 2 raised to n minus 1 combinations, right? Yes. So this is important thing to understand. Otherwise, we'll not be able to write the program for today, right? So that's why it should be clear. Okay. Now you can go through the. Okay. Yes, that's a good question. P1, C2, P1, C1, C2, C3. If you have the third fork, then yes, Priyank. But what is the third line in our program right now? What is the third line in our program? Print, right? I'm just doing fork and print. What is my third line? Print. Yes, all of you are clear? Yes or no? So that is why all of them will execute that print statement. Okay, so no more process will be created. But if your third line is fork again, then all four will create one more child. Getting? All four will create one more child. So that's why it is 4 plus 4. You will get total 8 processes. Now I think you understood the tree, Priya? Yes, so under P1, C1, C2 and C3, you need to draw 4 more children, right? One under each process. Okay. Now tell me what is a zombie process? Yes, anyone who have gone through that. Execution is completed but still available in process table. Yes, that's the correct definition. Child becomes zombie when parent is sleeping. Yes, correct. Dead and still alive. Yes, so you can say that, right? So basically, what Unix system has designed is every child, when it terminates, becomes a zombie, right? Whenever the child's job is over, right, or whenever it terminates due to error condition, it becomes zombie. So why do we need this situation? Right? If the process does not become zombie, right, and it goes out of the system, understand the situation. If the process becomes zombie, right, that is one case. And if process does not become zombie, okay, so if it does not become zombie, then can parent know what happened to child if process still does not remain in partial condition? I'll again repeat. If the child does not become zombie, right, that means it will go out of the system. If the child exits, right, can parent know regarding what happened to the child by doing anything? I hope now it is clear. Yes, it is depending upon the exit code, right? But to collect the exit code, the process has to become zombie, right? So that is why this is the important line. A child process first becomes zombie before being removed from the process table. Understand this. It always becomes zombie before being removed from the process table. Why? Because the parent process reads the exit status of the child, right? And then child will be ripped off, right, from the process table. Okay, so at least the process table entry of the child will be remaining, right? The other things can go away, but at least the process table entry will still remain, and that is why we say it is a zombie process. Clear? So dead but alive. Have we proved that point? Right? So if a child does not become zombie, can there be any issue? Can you give me some issue? Zombie is a concept, and it is also a state as well, Sinish, but we don't draw that in state transition diagram. It is described with a word Z, right? In Unix, it is a state. Yes, exactly. Parent will not be able to keep track of the child, right? That is a major issue, and that's why the concept of zombie has been introduced. All of you are clear with this? Yes, good, good. Fine. Next is orphan process, right? So as per the name, you can easily say orphan is something whose parent no more exists, right? So sometimes it happens that that parent process might die in between, right, due to some error or some you can say unexpected behavior. Fine. So should the child also die with it?
Sir, sorry to interrupt, but
Yes,
sir,
yes,
can you
yes.
just explain once again why zombie process is needed
Sure, sure,
precisely?
sure, sure. See, Sinish, basically, if the child goes without informing the parent, will that be accepted?
No, sir.
No, right? So we need some mechanism so that child can inform its termination, right, to the parent. Yeah.
Yes, sir.
So for that purpose, this zombie state has been introduced, right? Because if the child has already completed its job, is there any point in keeping the entire child process in main memory?
No.
No, right? Because you will be wasting your main memory space. Okay, so what they do is they remove everything except the process table entry of the child. Got it?
And to get the process table entry, the child
Parent
process
will get it.
means,
Parent will get that entry and then that entry will also be removed. So now we can say that child is completely gone.
so the entry will also be removed at the end.
Definitely, definitely. Right? Until that child is a zombie. Right? Until the entry is removed. Got it?
Okay, sir.
Yeah. Okay, so orphan. The question I asked you is, if the parent dies, should the child also die with it? Ideally. I'm asking about processes, right? Not in case of human, not compulsory, right? Because child might be doing some important task, right? So, but if the parent has died, we will lose the tree structure. Yes or no? We will lose the tree structure. Yes, right? And not to let that happen, right? Init becomes the parent. Init, whose process ID is 1, becomes the parent. Okay? So the process became orphan and it is getting adopted by the init process. Are you following this? Right? Process is becoming orphan and it is being adopted by the init process so that the tree structure remains consistent. Is that clear to all? Should I repeat? If required, you can tell me, right? Feel free. So these are important concepts, right, which we are studying. This is going to help you preparing for your competitive examinations also, right? This kind of concepts and questions are being asked in many competitive examinations, so you should know. Okay, so we have seen three major concepts: fork, zombie, orphan. All of you are clear up to this? Yes or no? Say yes if you are clear. Okay, does init process become zombie when computer shuts down? Actually, Shail, there is no parent of init, so that is there is no point in making it zombie. I hope you agree, right? Yes, daemon is a separate concept that happens in network. Right? Is a network-based concept, right? So it has its own reasons, right? Yes. Okay. So there are so many concepts, right? But right now we are just focused on the process creation. That's why I'm focusing on zombie, orphan, and fork. So I'm limiting myself over here, right? Yes. Okay. So task one, we've done, right? Call for once, twice, and thrice. Print hello. All of you have this program with you? Yes or no? Three forks. Save this as your first program for this lab. Save this as your first program. Yes. Sure, sure. Orphan. See, orphan is something like when parent dies due to some reason, but the child process still remains. Urjit, is that much clear? Because child is doing something, right? Important. So, but now, if the parent has died, then the child becomes disconnected from the tree. Agreed? Child becomes disconnected. So if you don't assign it some parent, you will be able to will you be able to keep the track of that process if no parent is being assigned? No. And that is why init adopts that process. Right? Init becomes a parent of that orphan. Got it? Yes, always. That's true. Because otherwise the data structures will be violated, right? And you know when data structures are violated, you will lose a lot of information, right? I'm talking about tree over here, right? Yes, yes. Good. Why can't we? So yes, that is also possible. But what if parent of parent might also die, Vidur? Because these are user processes, right? So that's why mostly, or you can say always, it is adapted by init process. Right?
Sir,
Yes,
sir, as Vidur has said, but is it always that case that parent of parent will also know more?
not always, but see, it things can go wrong, right? So that's why Unix designers have designed that whenever someone becomes orphan, It will be adopted by init only because init is going to stay, right? As long as the system is online, right? Yes, yes. Okay, now I'm giving you next task. Print hello from parent using the parent process and hello from child using the child process. Can you do this? I want two separate outputs in the same program. Parent process should print hello from parent line and child process should print hello from child line. Yes, try it out, surely. Right? Remember one thing, fork returns with PID of child in the parent and it returns with 0 in the child. Okay, that concept will be useful over here. Okay, I'm writing down that concept in the chat box. Use that as your reference. Fork returns PID of child to parent and 0 to child. Okay, so you need to use these values to achieve this task. Task number 2. Take your time and report me your status. Okay. Good, good. So can you all write down the pseudocode which you tried out? Just the pseudocode, right? Not the entire code. I just want to verify whether all of you are working on the same line or not. If PID is equal to 0, then child, else parent. Yes, that's one way. Very good. Anyone else who has tried if fork equal to 0, hello from child, hello from parent. Very good. Very good. But don't you think we should always check about the error condition? What is the error condition in this situation? Yes, yes, right. So you should also add that to your code. Are you getting the point? Yes, you should also check for the -1 situation because we don't know what might go wrong. Yes, Urjit, as I told you initially, the reasons can be we are not having sufficient memory, we are not having privileges to create a process, right? In that situation, the call may fail, right? So we should write a generic program, and that's why the first condition you should check is if it is -1, then you print with error, right? Otherwise, you print as per the normal situation. Right? Okay, so I'll wait for 5 more minutes and then we'll discuss the remaining task. Okay, 2:30. We'll discuss the next task. Waiting for others to complete. Report your status once you are done. Okay, so your first program for submission will be, as I said, 3 times hello and its output. Sorry, 3 times fork and its output, right? That is task number one's first task. And the second task is this one. So those who have completed can meanwhile prepare that submission document, right? So that you can save your time. Second program is this: hello from parent using parent process and hello from child using child process. And as always, you need to include the theory of this fork, zombie, and orphan. I'll upload this document after this lab is over so that we can discuss it together. So theory part you can do later. If you want to execute PID is equal to -1, what to do? Okay. So right now, Urjit, there is no direct way, right, by which we can achieve the erroneous condition, right? But you can imagine a server process, right? If the server process is occupied with so many processes currently, right, and it is such that where it can no longer create another process, right? That is a real example of this, right? Generally, this is useful in case of server-based processes, right? Where you have number of processes lying in a process pool, right? And when the process pool becomes full, at that point, it will be written with -1. Right now, in our systems, it is not possible, right? Okay, so others, what about others? Others, I think I've got around 15, 20 responses. What about others? Are you able to do this or not? Those who have not responded, please respond so that I can know your status. If you write exit 0, okay, that is a question from Janil. In parent, then also child would execute. Yes, see, basically exit 0 is to terminate a process, right? You know that from C programming. And Janil, what do you mean by 0? You know, what is the significance of 0 as a number? It is success, right? 0 stands for success. So exit 0 will definitely terminate that process, right? But if the parent process terminates before the child, what will happen? We've just seen that concept. Yes, child will become orphan, right? And that is where there can be an issue. Okay, so again, it has to be adopted by init. So we'll see a way by which we can control the execution. It is coming soon, right? Just after 10 or 15 minutes. So we can wait till that. Right? How to control which process to run first. Okay. Yes, good. Fine. Now I think we can go ahead. So next, two system calls. Now I'm going to cover this in the document itself. You don't need to read that. Right? Get PID and get PPID. Right now, as the name themselves say, get PID. That means you can fetch the current process ID. Right. So if the child is calling this system call, what it will get? If child is getting get PID system call, what it will get? Think and answer. Child is calling get PID. See the definition? Get PID returns process ID of calling process. Who has called this get PID? Who has called this get PID? Child. Yes, yes. That is why it will get its own ID. It will get its own ID. Is that clear to all? Right. So whenever a process wants to print its own process ID, we use get PID system call. Whenever a process wants to print its own process ID, we use get PID system call. Okay. Then the next is get PPID. So what this extra P is for? Can anyone tell me? Yes. As a child, okay. Now I'll take you back to the concept of fork. Yes, all of you have given correct answer. I'm happy with that. Fork returns with 0 in the child process. Remember that? Fork returns 0 in the child process. Okay. So if child wants to know its parent process ID, if child wants to know its parent process ID, what it will do? Get PPID. Exactly. It will call get PPID. Good. Right? Now listen to the second question. If parent wants to print child's process ID, if parent wants to print child process ID, what you will do? Parent wants to print child process ID. Return value of fork. Very good. I was looking for that answer. Right? So you need to store that return value into some integer, and that integer value is nothing but child's process ID. All of you are clear for these two questions. Good, good. Right. This is important, right? So that's why I'm taking time. Okay. So again, the header files are there, systypes.h, because we are looking for the data types, special data types, right? That's why it's systypes.h is involved over here. UniSTD is mostly having definitions of most of the system calls, so that's why it is always going to be there. Fine. So read the task number 2 and tell me whether you can do it or not. Read the definition of task 2. Can do that. Print PID and PPID for parent and child. Can you do that? Yes. Try it out. Right. I'll give you the format in which you should print. Okay. So what you should do is, I'm writing down that in the chat box. Hello from parent of child this line you need to print in the parent process. Hello from parent, then get the value of parent process ID, right? Of child, right? Now print the value of child's PID. Okay, in bracket you need to replace the value. Okay, and similarly, hello from child child PID of parent. Yes, yes, you can modify the same code, but make sure that you save the second code as your second program. This is your third program, right? Parent PID. I want your output to have these two statements. Is the output understood? Please look at that once. Right? Yes. So try to achieve this. Yes, Urjit, I have written the second statement also. Hello from child, right? In bracket, child PID of parent with parent PID. Uh, can you understand that as well? Second one. Let me know if there is any other query with that, right? Yes, yes. and let me know once you are done with this, right? And remember, this is your third program for submission, right? Good. I'm getting some responses. I'll wait for 5 to 7 more minutes, right? Till that you complete. Okay. Okay. Good to see the multiple responses. I hope all of you are clear to this, right? Fourth concept we have covered is how to print the process IDs. Okay, so I'll wait for 2 more minutes, right? Then we'll continue with the next task. Till that, those who have finished. Yes. Uh, Hello from child PID of parent, PID means child with parent ID. Yes, exactly. See, Pujit, as I said, if child wants to know its parent process ID, what you can do for that? If child wants to know its parent process ID, we'll use get PPID, right? So that's what I wanted you to use over there, right? And how it will know its own PID? Okay. Let me explain both these statements, right? So that you all are clear. Right? First statement was this. Okay, let me. Hello from parent in bracket. You need to print its own. So in this case, right? Hello from parent in bracket. Which function will you use? Can you tell me? Parent will like to know its own PID. Get PID? Yes or no? Yes, exactly. Right? In the second bracket, what will you fill? In the second bracket, return value of fork. Right? Suppose you return PID is equal to fork. Right? I'm not writing the complete syntax over here. If you return integer PID is equal to fork, right? So this PID can give me the child's process ID? Yes or no? Yes? Good. So that is the first line. Okay? The second line is hello from child bracket of parent bracket. Right? So if child wants to know its own PID, again we'll use get PID. Okay? And how will the child fetch its parent process ID? Second bracket, get PPID. Exactly. Now I think all of you are clear. So can you see a mapping between those four values that you are getting? I'm not going to look at all of your output, but I think you can verify it automatically, right? Yes or no? Yes. It forms an X, right? Yes, exactly. All of you are able to verify that? Same in cross, right? And that is very obvious, right? That is very obvious. Okay. But what might happen if parent dies before the child? Then the values might change, yes or no? If parent dies before the child, what will be printed as get PPID of child? I'm repeating the question. If parent dies before the child, what will be printed as get PPID of child? 1. That's correct. That is init. So, good. All of you are clear. Yes or no? Clear with this? I hope you are understanding and liking these concepts, right? Because this is a very interesting part of your OS subject, right? Where we study the process, right? This is the crux of that. Okay. Now the question is, should we let child run first or should we let parent run first? What is the ideal thing if you think about the tree? If you think about the tree, what should happen? Parallel, yes. If you have multiple CPUs, we can go with that. But we can think about single CPU system. Then parent will run. Yes, that is true. But parent will wait ultimately for child to complete. Yes or no? Parent will execute for some time. Then it will assign some task to the child. Like shell executes your ls command. Right? So it is waiting until ls finishes. Is it happening that without printing ls output, shell is closed? Is it happening anytime? Without printing any output, shell never closes, right? So, can you think what goes in background? Shell process waits for that ls output. Yes or no? Shell process waits for that output of ls, and once it is printed successfully, it goes ahead. Okay. So we need to put a break over here. Yes or no? We need to put a break on parent, right? And how do we do that? Using wait, using wait system call. Okay. So wait is a special system call which is issued by the parent, which is issued by the parent to wait for its child. Okay. And whenever child returns, it can return a specific status. That is whether it completed successfully or whether it completed with failure, right? Or if we are not interested in the wait status, right, then child returns with null ideally, right? So wait can be used in two ways. One of the ways is to use wait with null, right, in the parent process, right? What this will do is it will make your parent process go into block state. Understand? It will make your parent process go into block state. Okay? And it can resume only when the child is complete. It can resume only when the child is complete. Is this clear? Wait will make your parent process go into block state because we want child to complete its job, right? So then the chance will be given to the child will complete, and then the control will come back to the parent. It is just like you are calling a procedure, right? You know, you have studied those concepts, right? Yes, exactly. It doesn't care whether it is success or failure. That's correct, Sanish. Right? It is just like we are giving we are passing on the control to the child. Child will complete anyway, right? And the control complex comes back to the parent. Clear, all of you, with this much? Yes, right? So wait with null is one option, and another over here, as given in the document, you can also get the status of the child using Suppose I declare an integer variable, integer status, right? And then I'm writing weight like this, weight and person status. Okay, this is another way. So this status variable will hold the child's return status. Status variable will hold child's return status, whether it is successful or failure, right? That is going to be stored over here, right? Mostly we use weight with null unless we are interested in the return value. In upcoming labs, wherever required, we'll go with the weight ampersand status signature. But right now, you can go with this much weight with null. Are you clear with both the applications, both the uses of weight? If you pass a reference of the integer variable, that means it will store the child's return status in that location. Okay. If you are not passing anything, it will just wait until the child completes and the control will be back. Clear, right? So any of the way you are comfortable, you can use wait with ampersand status with integer status declared or wait with null. Okay. Now let me describe the task. Task number 3 or your program number 4 it will be, right? Am I correct? Program number 4. Sure, yes. Wait with status, right? Basically, every child returns with some status, right? So either success or failure, there are specific numbers denoted for that, right? So if you want to know what is the status of termination of that child, right? Then we can pass wait with ampersand status. So that status location will contain the reason of child termination, or you can say the status of child termination. Right? But if you are not interested, you can go with weight of null. Okay, and mostly we go with weight of null because we are not concerned about the return right of the status. But if you are writing a server process in complex Unix programming, then you might require this status value. Okay, fine. So you need to wait. You need to add weight to the code of task number 2. That is, which is task number 2? This code where you printed hello with PIDs. Okay. I want to make sure that you should get hello from child message first, right? Hello from child with the PIDs should be printed first and then hello from parent. I want parent to wait until child completes and then message from parent should be printed. Is the aim clear? Yes or no? Is the aim clear? Yes, so try that out. I think it will take around 5 minutes, a small change. Okay. Still I'm waiting, right? If you want, I can give you more time. Okay. So try this out as your next program. Okay, so those who have written done, are you getting hello from child first? In every case, you try to run the same program at least 5 times, right? Run it 5 times at least. Because whenever you are working with processes, we should not rely on one execution, right? Twice parent is printing with its own ID. So yes, so in that case, Urjit, have you written multiple printf statements in your code? Is that so? Otherwise, it cannot happen if there is only one printf. Yes, so those who have written yes and done, have you verified it 5 times at least? If else if condition, then there should not be an issue. Urjit, can you send me your code? I'll just verify, right? Send me an email. I'll just verify and we'll be back to you, right? Yes, yes. Wait is before printf. That's correct, Ronak. Because yes, yes, that's right. We are talking to Urjit. Urjit, just check it out whether you written wait before printf or not. Yes, if it is so, then I need to check once again, right? You send me a code. So basically, the first line in the parent should be what? The first line in the parents part of your code should be what? Can anyone answer this? First line in the parent is for or wait. If you written if else if, then the first line is wait, isn't it? Janil, I hope you are following. Yes, right. After fork, we write the if condition. After fork, we write the if else if later. Right? Got it? I hope all of you are following the same structure, right? After fork line, we are going with the if else. Okay. Yes, yes. And then it is up to you whether you want to check PID is equal to 0 first, or I can also go with PID greater than 0. If PID greater than 0 is the condition, which part will be that? Which will be that process? Yes, it will be parent. Very good. Right? So that is another way of doing this. Okay. So I hope all of you are clear up to this. Yes, absolutely clear. Answer this confidently, right? So that I can give you the next task, because next task depends upon what we have learned. Okay. If you are confident, then answer yes. Yes, good. I'm getting multiple replies. It's nice to see. Okay. Now it is 2:55, so we have the important assignments till the lab ends. Right? We have enough time to complete that. Right? Don't worry. In OS, generally we try that you can complete your lab work within the lab time, right? So that you don't have to spend extra time over here, right? First is we need to implement a fan of n processes, right? Now, ideally, all of you are having fan at your home, right? So if you look at the structure, we have a central component and you have the wings, right? That is the structure of your fan, right? So if you try to map that on the processes, right? Just look at this diagram which is there over here. In center, I want to have a parent process, right? And at the radial angles, I want the child processes. Okay, are you able to understand the structure? What is fan, right? So how can we control this? How can we control this? Can anyone give me some idea? Same parent has to generate multiple child processes. That is the basic idea. Got that concept? Same parent should be able to generate multiple child processes. Yes or no? Clear with that? If in child it won't fork, we need to submit task. Yes, yes, both the things, Janil. So I think you've written 4 programs up till now, right? If I'm not wrong, or 5 programs. 5 programs. With wait, it was fifth, right? Yes. So those 5 plus 2 more, we'll have 7 programs in total. 5 plus 2 more. Okay. Yes. So this is the logic you need to control. Yeah, so it is up to you, Bhavik, whatever structure you want to use. But what I want is this, right? I'll give you the output format, right? If you are clear with the logic, should I give you the output format, all of you? If you at least thought of the logic. Okay, that number you can read from user. Priyank, read from user. How many child processes you want to create? Yes, sure, yes. See, I want same parent to create multiple processes. Up till now, the parent has created one child, right? But what I want is the same parent should also be able to create other children. So if user is entering 5, you should be able to create a fan of 5. Got it? Yes? Fan of 5 processes. So that is what is the logic. And the output format. Now I'm giving you, focus on that in the chat box. So again, hello from child ID of parent ID. This line I want you to print 3 times if it is fan of 3. Okay. So what will be common in all printf statements? That is all in the all outputs. Suppose I am giving fan of 3, then what will be common? Yes, exactly. So you can verify correctness of your program yourself. Are you getting this point? Yes. You yourself can check whether your program is correct or not. I don't need to check that. Okay. That is the first thing. Now let me explain you the next task also, so that you can continue in the remaining time. Okay. Chain. Now observe the figure and tell me whether you understood or not. Write a program to implement chain of n processes. Are you able to understand the logic? And the difference between the first program and the second? Yes, yes. So Yash has written yes. Multi-level, which is the saying, child of child. Yes, exactly. So it is like we want to create a chain, right, of n processes. So if user enters n is equal to 5, okay, then you need to create chain of 5. Okay, that is what you need to do. So parent will create a child. Okay, the child will now become a parent. The child will become a parent. It will create another child. Okay, that new child will again become a parent. It will create another child. Following this, that's what we call a chain, right? So if you will do the first one, the second will be easy, right? So focus more on the first task. Once you are done with that, second will not take much time. Okay. Still, if there is any doubt, you can definitely ask. Okay, whatever system calls we have learned, fork, wait, get PID, get PPID, all of them will be used in these two programs. It is just like a revision. Okay, so go for it. It is 3-1. So you have enough time to complete. Yes, yes, sure, Gurjit. I can explain. I can give you with an example, right? So that you will be clear. So, hello from child 1, 2, 3, then 1, 2, 2. So the first line, then comes 1 to 4 of parent 1 to 2, right? Then comes 1 to 4 of parent 1 to 2. Can I say, Urjit, this is the output of fan of 3 processes? Sorry, 1 to 5 in the last one. Forgot to change that. 125 will be the last one. So why we are doing this? Right? We are doing this so that we can verify whether the child is getting a unique ID. That is the first thing. And is the parent ID remaining same? That is the another thing. Following this, Urjit? So that's why I want you to stick to this format. Otherwise, you could have written it in your own way, but otherwise, it, keeping track won't be easy. Yes, yes. And what about the chain program? How will you print that output? Or how will you verify? That statement I'm leaving up to you all, right? You decide the output format and prove that your output is a chain. Okay? That one thing I'm leaving up to you. Okay? Fine. So continue. Yes, sure, Bilva. I'll have a look at that. Yes, Urjit. Let me check. Hello from child 1 to 1 of parent 1 to 2. Hello from child 1 to 2. Okay, actually, don't you think that instead of 1 to 2 in the second line, it should be 1 to 3? Because now 1 to 2 will become a parent, right? Yes. So that's a small change, right? That's what you need to try. Yes. So it's good. You got the point, and the same output you need to achieve. Yes, sure, Udit. I'll just check it out and reply with the mail itself, right? I'll reply to your mail once I check it. Okay. Yes. Okay. Is there anyone who has not yet joined the classroom? If it is so, please join it as soon as possible, right? Because already 2 assignments have been posted and I have started assessing your submissions. So I want all of you to submit on time, right? Okay. Don't try to be late in submission. And as I told you, you will be able to complete your programs within the lab itself, mostly. Right? So you don't need to spend extra time on that. So if it is not yet submitted by any one of you, you submit the pending assignments, right, for lab 1 or 2. I'm giving you the classroom code once again. If you have not joined the classroom, do that as soon as possible. what you can do is you can post this classroom code in your group. So if someone is still not joined the classroom, they can join. Can anyone do this? Urjit General, if you have a WhatsApp group, uh, because I can see at least 3 to 4 students have not joined the classroom. Yes, thank you, Urjit. So please ask them to join it as soon as possible. Otherwise, their lab work will not be accepted for the previous labs, right? And I think Ashish sir has already announced that we have an extra class on Saturday at 9 a.m. Because we lost one lecture on Wednesday due to holiday. So all of you know about that. So please join at 9 a.m. sharp, right? On the same link which we are using. Because we need to still cover the 9 state diagram which is still left. Okay? So on this Saturday, we'll be finishing with this process chapter. I want all of you to be present over there, right? In next week, we are going to start with threads. That's why on Saturday, we'll be finishing with this. So an important diagram we are going to cover, 9 state Unix diagram. So we try to be present. And after my class, Ashish sir will take the class. You know about that, right? Yes, Preet. We'll be covering that once we study the chapter number 5, and we'll be starting with chapter 5 in the second sessional phase. As soon as we begin with second sessional phase, second teaching phase, that is. Right? So after your first sessional exam, we'll begin with mutex and semaphores chapter. And then we'll also practice the same in the lab. Because again, those concepts require a lot of discussion. So at least 5 to 6 classes we need on that concept. And then we will go for the deadlock concept, right? At the end of second sessional phase and in the beginning of third session, we'll cover deadlocks. Yes, Birva, are you there in the meeting? I would like to discuss regarding your doubt as well. Yes. So you are getting something like this, right? Hello. I think many of you might have seen this, at least some of you, right? If you are trying hello 3 times, then there will be a shell prompt in between. And then you will have remaining hellos, right? Yes, right? So why does that happen? Let me explain that reason. So generally we have a dispatcher in background, right? So whenever you create a process, right? Again, we are creating a child process, but basically it is a process, right? So who controls its execution? Who controls its execution? It is the dispatcher, right? Yes or no? So if you have total 4 processes, right? If you have total 4 processes, including the parent, okay? Plus you have one more process, that is shell. Yes or no? In your ready queue, right? If I'm calling fork 2 times, I'll have 4 processes plus the shell. Yes or no? In my ready queue, I'll have total 5 processes at least. Agreed, Birwa? Yes. So now in your case, what is happening is it is letting first two child run, right? And then it switches to shell in between because shell is also in ready state. Agreed? Shell is also in ready state. Okay. But then it realizes that shell is not supposed to do anything, right? And then it switches back to remaining child processes. So it is due to process switching. You are seeing that shell prompt in between. Is the reason clear? Yes, right. So this can happen to anyone, right? If you're working on virtual machine based Linux or if you're working with a pure Linux system, this can happen because all the processes are competing for execution, right? And shell is also a process, right? So your dispatcher mistakenly might schedule your shell in between. Okay? But again, it goes back to your processes. Right? This shell prompt can be any. Yes, exactly, Sainish. Not necessary that it will be in between, exactly in between. Right? You can get one hello, then shell, and three hellos. Yes, yes. It's a good point Birva has raised, and that's why I discussed this with all of you. All of you are clear? Yes? Those who are listening, this can happen, right? Yes, yes, good. Is it fine if it is in between? Yes, yes. That's perfectly all right, Harsh. Because see, we are not controlling that. Yeah, yeah. That's okay. In submission, you can keep it in between. Because do we have any control on dispatcher? Tell me. Do we have no, right? So that is the reason that shell can come in between. Okay. But if you want a proper synchronized output, then or at least if I say if we want proper synchronization between parent and child, what we should always use? You studied that concept today. Can you recall? Forget about shell now. Yes, exactly. Wait. That will make sure that your processes are dispatched properly, right? Yes, good, good. So how many of you are done with fan? Can anyone respond your status? First done. Very good. Very good. Okay, Nandini has a question. Let me check that. If we are using like int PID fork, then output is different from fork. See, basically, when you should call PID is equal to fork, Nandini, that is again one point. When we call it PID is equal to fork, when we want to distinguish between the parent and child, actually. Right? I hope you are following. Because then we use that if-else if structure. Yes or no, Nandini? Yes. So, but just for learning, I told you to call fork only, right? Fork only two times, three times, four times, right? But when we write the program, actually, we always write PID is equal to fork. So you should rely on that method only. Is that fine? That we did just for learning, right? Yet, yes, it will do because see, if you are not relying on the PID value, that means your processes can dispatch based on the dispatcher's logic. Agree? So when you run the program first time, dispatcher will schedule them in a different order. When you run the program second time, dispatcher may select for another order. Yes or no? So it all depends upon dispatcher. That's why you are getting different output. Got it? Yes, yes, good. Okay, so I think first, and yes, Bhavik has done with the both the programs. Very nice. Yash has completed both. Good. As I said, if you will do the first one, second is on the same line, right? Yes, that's okay. Any way you can do it, right? No issues. You can go with a loop or recursion, no issues, right? Ultimately, you should be able to verify the output. Are you able to do that? First child becomes the parent, it creates another child. Second child becomes the parent, it creates another child, and so on, right? If that is happening, then logic is up to you again, right? How do you design? And yes, so let me post the document for submission, right? So that you can just follow that. And in the theory, as I told you, you need to include description of fork, weight, right? Then, okay, write that down over here. Fork, weight, get PID, and get PPID. These four you need to describe with syntax and examples. And then it will follow with 7 programs, right? Am I getting the count right? Total 7 programs and their outputs. Okay, when it comes to end in the second question. So, Sainish, it depends upon the input. If you say that you want a chain of 3, right, then you create 2 children only. Okay, then it will come to end. Okay. Chain of 5 means 4 children. That's how. Right? And one more thing before we end. Next time we are going to have a lab on threads concept. So I want you to at least revise functions in C. Right? How do we call C functions? How do we pass parameters? Will you do that? Function calling, right? In C. Customized function when we create. How do we pass the parameters to the function? All those things we require, right? So that we don't waste time on those concepts. Because in threading we'll require that. So over here we are done with the system calls are functions only, yes. But you can say they are high privilege functions. They are written as a part of OS, Harsh. Right? They are just normal C functions only. But they belong to a separate category. That's why they are called system calls. Okay, so I think the time is about to over. So you can leave the meeting if you are clear. Right? Fork 3 times. Hello from CFP. Hello from. Yes, that's correct, Chandresh. That's correct. 7 programs. One is okay. Let me go through the. And one is this, right? Call fork once and twice. Hello from parent. That is second, right? With PID is third actually. Okay, so I consider that fork once as the first one, I think it seems. You can go with this index which you have described, Chandresh. It's okay. Yes, surely. I'll be posting the submission in 1 minute only, right? Just 1 minute, yeah? Okay, okay. Yes, that's a good question, Preet. OS is generally installed on a single system, while distributed OS is actually decoupled, where the different components of the operating system are distributed on various machines. Right? So you have multiple hardwares and a single OS. That's what we have in distributed OS. Understood? Preet? Your OS functionalities are distributed on various machines so that you can achieve more parallelism, you can achieve more performance. That's why. Right? The OS which we are using is a single standalone OS, right? Where we have everything on the single machine. So I have posted the assignment. If you don't have any doubt, we can leave the meeting. Have a good day ahead.